Good afternoon, everyone. I warmly welcome you to our third AIEI Tech Talk with NVIDIA. You are with me, Parinya Kuntuam, or you can call me Drait, and I am a moderator for today's talk. Let me tell you a little bit about our series of this Tech Talk. This talk will give you a special opportunity to get knowledge from international professionals who give you the functional language you need for real life, hands-on tasks in the technical, industrial, and scientific fields. And right now, the talk journey has come to the third episode on the topic of introduction of accelerated data science. And our today's speaker is currently responsible for growing NVIDIA's accelerated data science and machine learning developer practice in the Asia Pacific South and ANZ regions, with over a decade of expertise in scaling and enabling enterprise AI in region. And he is passionate about supporting the developer ecosystem in their AI journey. Please welcome Dr. Deb Goswami.
Thank you. Thank you so much, Parinya, for that very warm introduction. It's a pleasure to be here today and speak to all of you. And I'm looking forward to showcasing a lot of what NVIDIA has to offer in the structured and tabular AI field. So without further ado, let me pull up my slides and I will need a few thumbs up from you guys once they are on screen. So, okay. Can I get a quick thumbs up from someone if you can see my slides? Looks good. All right. Thank you so much. Hi, so welcome to today's talk. I will try and keep it breezy and engaging, so keep your questions in the chat, if you will, and I will try and address them. There are a few points in between where I'll stop and take a few questions. So what I was looking to do today is to give all of you a bit of an overview about NVIDIA and our AI journey, because a lot of you may know us as a gaming company, which of course is what we are really known for when we started the company nearly 30 years ago. I'll spend a little bit of time talking about industrial applications for machine learning and how NVIDIA looks at AI across the board, from deep learning to regression algorithms and XGBoost and even data and big data processing. Okay. We'll then spend about 10 minutes or so going through a quick demo on how to use NVIDIA SDKs on your development machine. And of course, nothing gives me more pleasure than to take your very insightful questions. So keep them coming. Okay, so NVIDIA, the AI company, right? One of the quotes that Jensen, our founder, likes to say is that we build the tools to empower today's Da Vinci's and Einsteins. And that's certainly something that I've seen happen. It was probably about 15 years ago now, and I was reading for my PhD, and it was in face recognition before deep learning. And at the time, you had to take small parts of the problem and solve and design rather, for the time, sophisticated machine learning algorithms to solve. And one of the areas I was looking at was taking 3D scans of faces, transposing them into 2D, and then trying to learn some substructure mapping and some substructure information to see how these faces evolve over time in a recognition scenario. And NVIDIA hardware, even then, were what we used to accelerate a lot of these processing. What's interesting is that our journey from a hardware perspective has actually taken an interesting route. We started off with GPUs, and a lot of you probably know of our efforts in revolutionizing the AI field via deep learning. But very interestingly, it is our networking and scalability journey that often goes under the radar, because in the 90s and the 2000s, some of the largest consumers for GPUs at the time were render farms and studios that made animated films and special effects studios. And we're talking about, render farms that have 1,000 computers in there in a cluster. And how do you manage and orchestrate 1,000 computers working together to make one 118-minute feature film? shunting huge amounts of data and very complex scenes across different nodes and rendering different parts of the film and going back and forth. So it is the networking and the scalability journey of NVIDIA that a lot of people get taken aback by. And once the AI revolution really came to the fore, and it became a lot more ubiquitous and commonplace for nearly every company to have some sort of AI, you will find that NVIDIA solutions tend to provide a huge degree of scalability to these large players, right? So as of today, we're delighted to talk about our software platform and what we enable across the world. So we've got over 1 billion CUDA GPUs that accelerate workloads. We've got over 2,000 GPU apps, nearly 24 million downloads and going. We've got nearly 200 SDKs at this stage and about 12,000 AI startups, right? So even in the time that we've made these slides, we're kind of moving at the speed of light. And we do this for organizations and startups and enterprises and research institutes across nearly every vertical that you can think of, from computer vision, which some would consider to be our bread and butter, all the way to healthcare or scientific AI, autonomous vehicles, and even gaming. How that tends to work when we engage with different players across the industry is we provide an end-to-end journey for a lot of these players. So we have something in it for developers and data scientists. We've got something in it for the IT administrators. We've got a lot in it for people from organizations and leadership and how they figure out which parts to put on cloud and on-prem and have hybrid infrastructures. And of course, when it comes to the use cases we enable, it's pretty universal across the board. So the way to think of us and the way to think of engaging with NVIDIA is way beyond the hardware. And it's along the lines of what SDKs can we use? And this is where things get interesting. And what a lot of people are very surprised by is the fact that NVIDIA's software libraries are best in class when it comes to scalability and performance. Case in point, did you know that Amazon.com's real-time spell check for their product search is powered by NVIDIA hardware and software? We work very closely with the Amazon development teams to productionize their language models that are served using something called Triton Inference Server, and we'll get into that in a bit more detail. And that basically took the time needed to find the optimal configuration from weeks to hours. And for an organization that is as large scale as Amazon, these are huge savings as well as efficiency optimizations. American Express and their real-time fraud detection algorithms run using NVIDIA hardware and software. And if you think about the use cases, as somebody who may have as a consumer, a lot of people tend to place trust in brands, and especially when it comes to your hard-earned money. So money laundering can be a real problem. It's a very cat and mouse game. If any of you are ever interested in sort of cybersecurity and financial data science, you will find that it's a very dynamic landscape. You create a barrier and malignant actors work very hard, as hard as you, or if not harder, to try and find a way around it. So it is very important to have systems that are agile, systems that are very high performance, very low latency, so as to really minimize the opportunity for your network to be hacked. For the US Postal Service, we have a very interesting use case where we combine both their physical package inspection, damage classification, as well as their analytics workflows, where they try and understand how many packages went through a plant, which plants have an efficiency issue, and so on and so forth. We've done this for Walmart as well, who are one of our best consumers. And closer to home, closer to this region, we worked with the Ant Group and the Alibaba Group. And on Ali Cloud, we were able to find significant collaborations and have huge improvements and huge efficiency improvements for their compute stack. Okay? So that's NVIDIA, right? That's the kind of scale that we do, and we're so privileged and delighted to work with some of the world's largest AI workloads. And how does that translate to data science and doing data science with NVIDIA? Because for a lot of you, your first, certainly a few years ago, the first encounter with machine learning was this incredible course, and it's still up on Coursera by Andrew Ng. And he would have this fantastic course where we spoke about predicting house prices, and Python as a language is something that a lot of us data scientists use today. But that journey kind of began a lot earlier, and this is what we, for example, enable just for financial services. So data science today is a field that is not limited to quote unquote technologically advanced organizations. You have small, medium enterprises who need analytics to try and understand how their consumers are behaving, to find inefficiencies in their processes, and to try and establish new product lines so strategically. So these are the decision enablers for organizations. You will have data science teams doing a wide variety of use cases. So let's go into these in a little bit of detail to try and help you understand how machine learning gets used in the enterprise, right? So there tend to be three broad types of data product deliverables, right? One of them is insights. And insights could be where your chief executive officer tells his management team that we need to grow our revenue by a certain percentage next year. And I think this particular business line has the opportunity. They could then have a conversation with their business teams and their data science and data analyst teams and say, we have a few hypotheses, can you help us? So these insights can often take the form of reports, they can take the form of thought pieces, they can do a bit of hypothesis testing where they say, well, for example, what happens if we increase the price of our product by 5%? What happens if we decrease it? Do we actually make more money, right? Does it increase our reach, for example? So that's one type, right? Then there's data products. This is where things are very interesting, and a lot more software engineering comes to the fore, right? So you're talking about building what's known as an API, or it could even be a computer program that resides in the cloud and is run on a repeated basis, batch jobs. And finally, you could have product and user recommendations. So the most famous recommendation, again, is when you go to Amazon and you're clicking on and this is ubiquitous across any e-commerce platform today. But of course, when it first came to be, it was very revolutionary. And you go to a product page and you click on an item, and below they say, people like you also looked at this, or people who bought this also bought that. And if you're opening any mobile app these days, you will find these scrolling carousels or grids. And more often than not, there are data science teams working to make sure that every single item in that is tailored and personalized to your interests, right? So these are three broad categories of data deliverables that a lot of machine learning teams work on. And they are always geared towards, or they should be geared towards a business outcome. If they aren't, then that would be a research product. And increasingly, you'll find organizations spending a certain amount of time, like 10, 20% of a data scientist's or data science team's time on research, right? Where you do not necessarily have to peg it to a business outcome. But by and large, most data deliverables tend to be attached to a specific business outcome, whether it be content discovery. So for example, for a platform like Netflix or any video streaming platform, they might have, one of the teams might have a KPI. They might say, what percentage of all the movies and series and cartoons and animes that we have is actually discovered by the user? So for example, if I'm paying for 20,000 or 30,000 titles in this region, and less than 15% of these are actually discovered or watched by our users, then perhaps I'm wasting money, right? And vice versa. If it's a saturation point, if nearly 80%, for example, 90% of my content is being watched, then that means I should get more, because that means people have an appetite for more, right? Ads targeting, which ads, for example, whenever you load up most of these news websites or any website with content, you will find an advertisement that is attempting to be triggered to your personal interests. We spoke about fraud earlier, demand forecasting. So if you are in an industry that purchases huge amounts of inventory in bulk in advance, it is important to know, is the price of this commodity going to go up or down in the next 6 months? For example, if I'm buying $20 million worth of a specific commodity, then it's important to know whether the amount that I'm placing aside from a budgetary perspective is enough. And if it is too much, then that means I'm not spending my money elsewhere, which could be used, right? So very interesting dichotomy. Search ranking, again, with Google, and how do you get to decide and design a system that gives you the most relevant results at the top? If you are a business, you may also wish to have certain advertising or priorities based on how you offer services. Customer retention is for platforms that have subscription elements. It is very important to try and keep your users happy, because that's what most platforms like to do. So customer retention, a lot of analytics teams will try and work on approaches to keep a customer online, right? So to take the video platform, let's say you're an avid anime watcher or an avid drama watcher, they will try and provide opportunities for you to engage with that platform. When they find you getting bored, suggest you new things, right? And you've got lifetime value, which from a business perspective reflects how much the customer is likely or has already spent on your platform. And I want to try and prioritize, and perhaps you want to bring everyone to specific lifetime value. And CRM systems, of course, customer relationship management, where for a lot of companies that sell to other companies, or if you have leads, then how do you enable all of these things, right? How do you build machine learning and AI that aids these verticals? So having said that, how does a data scientist and what does a data scientist actually end up doing, right? And I love this graphic because certainly as I was starting my career in data science nearly over a decade ago, and one of the things that I made an assumption on is that it would be the mathematics, it would be the programming of the APIs that would be the most challenging part. That can still be true, but chances are it's actually getting to the data in the first place that takes a lot of effort. And this is where a lot of data scientists, data engineers, data analysts, especially as you're new in the field, it is incredibly important to appreciate that if you're using Python and using scikit-learn, the dot fit part of your process is probably step 99 out of 100. Right? So there are 98 steps before that, before you can actually build your model. And a lot of that involves talking to your business stakeholders, your engineering teams, speaking about how and why this problem is actually important to solve, getting the data in the first place. And we'll speak a little bit about that in the future. But it's not a given that you will get a structured, nice, beautiful CSV with which to train your model. In fact, a lot of the time, you have very messy data. So a customer, for example, let's say you have a data set that speaks about a customer's purchase journey. What happens if they lost internet connection while they were pressing purchase? One system might record that they pressed the purchase button, but another system, it would have been broken in between, so they may have not logged it. So you have two data sets in the background, one saying the customer bought something, the other one saying the customer didn't. How do you align that, right? And these issues are, it's a relatively simple one that I explained. Some of these systems are very complex. You have 5 or 6 different stages between a single button press and actually a piece of data getting recorded in a database somewhere. So it's very important to have good data skills. That means know your SQL and your Python. I think those are two absolutely essential languages that you will benefit from as a data scientist. So that brings us to NVIDIA, right? And a lot of you who may have been interested in the machine learning and AI field may think of machine learning as an iterative process, and you would be right. You have an idea, you try training a model, say, yep, this is my best solution, let's deploy it, right? Let's put it out to the world. And when it comes to working with huge data sets, and these days, big data, the benchmark for something almost qualifying as big data is getting higher and higher. In fact, even petabyte level data these days there are solutions that handle that almost routinely, right? So where GPUs aid you is in accelerating every stage of the process. And what NVIDIA have is a pretty sophisticated software stack that is Python-based that allows you to use your existing machine learning tools and frameworks and just add GPU compute to it, right? NVIDIA tends to, we've taken it upon ourselves to design these SDKs with 3 design principles in mind, right? One of them is performance. So most of the time, if you are using an NVIDIA library, you're probably going to get the best performance bang for buck, right? The second design principle that we have is scalability. So whether you're using a single CPU, a single GPU, or 100 or 1,000 node cluster, the same code ought to work. Thirdly, if it ain't broke, don't fix it. So we build our SDKs with as familiar an interface as possible. So if any of you have heard of pandas, and I'm sure you have, if you've been a data scientist, then I'm sure you're aware of the pandas library that allows you to create data frames with which you can do quite a few operations and do group bys and filters and aggregations. Well, Rapids, which is NVIDIA's structured AI SDK, we have Rapids pandas functionality within that. With the same interface, with the same linguistic syntax, you could have GPU access. If you've heard of scikit-learn, pretty much every single scikit-learn machine learning algorithm is available for acceleration on GPU. If you work on probabilistic graphical models, if you work on deep learning, and even if you want to do visualization, we've basically got SDKs that are identical to the best-in-class platforms for those verticals. So this is where NVIDIA Rapids sits in the grand scheme of things. You've got, let me see if I can use my laser pointer. So this particular slide, let's start from the bottom here. NVIDIA SDKs tend to be run nearly everywhere you can think of. So whether it's on-prem, on-premise, on your local machine, or on your cloud platform, you will basically have access to NVIDIA SDKs there. Magnum and CUDA are amazing SDKs, but most data scientists probably don't encounter them directly. Unless you are writing C++ code for your machine learning workloads. Where things get a bit interesting is in the data processing layer. So we spoke about pandas. So Dask is NVIDIA's answer to pandas using GPUs in a distributed manner across a cluster, right? And just to clarify, in case we're wondering, so when I say cluster, I mean a group of computers that are bunched together and trying to do one task, right? So let's say you wanted to decode, or you wanted to run a machine learning training algorithm, and you felt one machine was not powerful enough. You want to spread the load across 2 or 3 machines, then that would be called deploying that training job to a cluster, right? So that's what we kind of have enabled. So distributed pandas at scale. Spark, Apache Spark, is one of the most popular distributed data platforms, and we are delighted to say that as of Spark version 3.0, you have the ability to, if you put a GPU onto your Spark cluster, it is resource aware, the yarn scheduler is resource aware, and is able to accelerate those parts of the code that are GPU compliant, right? And where Rapids sits is basically here, on the machine learning layer. Anything that isn't deep learning, the way to think of that is Rapids, NVIDIA's Rapids, right? And we'll get to deployment later. It's called NVIDIA TRITON. And as we spoke about data products earlier, we also mentioned something called APIs, right? So an API, the simplest way to think of an API is it's a question answering machine for machines, right, for computers. Basically, it has a preset format with which you ask it a question. And once you give it that question, the API is responsible for answering your question in a specific time, right? So for example, a simple API could be, if I give you this piece of text, can you tell me how many named entities there are? Right? So by named entity, I mean the piece of text could be a sentence saying John went to a bar, and you want to know that John is the name of a human, bar is a place, and went is an activity, right? So that could be the answer that your API returns, right? And you have, so APIs tend to be the backbone of most machine learning deployments, and NVIDIA's Triton SDK is our way of enabling that. So imagine an enterprise that has hundreds of APIs out there at the least, right? Every data science team is building more and more, right? One of them is a credit scoring, the other one is an OCR API. One of them says we've got an eKYC problem. Let's do that, right? Okay, so Rapids is basically NVIDIA's answer to structured machine learning. And if any of you have heard of XGBoost, we're delighted to say that XGBoost runs on GPU with no change to your code. Can I get a quick show of hands as to how many of you have heard of NVIDIA? Of Kaggle, or Kaggle competitions? Just do a reaction if you can on screen. Okay, so if you haven't, do try it. Kaggle is a fantastic platform for any aspiring data scientist. What you get is the ability to practice your machine learning skills with data sets and problems. So there are different challenges within Kaggle and competitions, and what they do is they will give you a data set, they will give you a problem to solve, and that whoever designs an algorithm that works the best wins that specific competition. That's roughly the thrust of Kaggle, right? And XGBoost is one of the most popular algorithms. It's very versatile. It handles nonlinearity and a variety of use cases. And basically, you can run that on GPU with no change to your code. In fact, on the left-hand side here, you've got XGBoost code on a CPU, and you literally just have to add a tree method GPU hist argument with the same code to be able to run on a GPU with significantly faster training and inference times, right? We spoke about data processing and NVIDIA's approach to enabling Spark. I won't go into too much detail on this slide, but basically what you're seeing at the top here is what it used to take on CPU on a vanilla HDFS cluster, and what that looks like when you incorporate Rapids GPU accelerated ETLs. So we spoke about the importance of data. A lot of organizations have what's known as data engineering teams. We also spoke about how data can be messy, right? So imagine that example where we spoke about somebody losing internet connectivity as they're clicking the purchase button. Well, data engineers, one of the things they do is they're responsible for data that gets written to a database to be accurate. So they want ETL, they call extract, transform, load pipelines, and basically they take raw data as it is, they incorporate some rules and they process it, they clean it, they deduplicate, denoise, impute, fill in the blanks, and put in a final version of the data into the data warehouse that is actually used by, or fit for, certified as fit for use. So an ETL pipeline can be very complex in terms of its code, its logic. It can also be very time consuming to run. So imagine this scenario where you find a bug in your data pipeline. Oftentimes what you then have to do is what's known as a backfill, right? So it's not enough to fix the bug in your code. You have to go back and fix that specific field's worth of data using the proper logic, right? For all eternity back, or however much is reasonable. So these jobs often mean doing 100 gigabytes worth of data for large organizations worth of backfills. So imagine something that used to take about 40 minutes, if you're really lucky, to about a few hours, now taking less than 10 minutes, or in some cases less than a minute, right? So that's the power of using GPU accelerated data processing, and it uses the same language that you're all accustomed to. right? So this slide again speaks a little bit about what a modern day enterprise warehouse looks like, and how Spark plays a role in enabling these workflows, and how NVIDIA accelerates all parts of them, right? This is a bit more advanced, but basically, if you've worked with Kubernetes, then all of NVIDIA SDKs tend to be Kubernetes native. And as of Spark version 3.0, all you need to do is put a GPU in your Spark cluster, and it's good to go. Okay, so this slide is an interesting one, and there are two parts to it. At the top half, you are looking at code examples, and code examples of the difference between using CPU and GPU code. And you will be hard-pressed to find a difference, right? So as I said, if you've got pandas data frames, you could very easily use cuDF data frames and use that as your data structure of choice, and you get GPU acceleration for free. On this hand side, what you have is running a regression model, and what that looks like using GPU versus CPU. It's the same code, right? All you're doing is changing your import statement, and instead of SK linear regression, you've got cuLinear linear regression, and that's it, right? You just pick the algo, and there you go. At the bottom here, you're basically looking at the performance improvement, and it's immense, it's massive, right? So you're basically seeing a huge improvement, between using 20 to even to 100 CPU nodes, and the single GPU workstation is enough to sort of blow them out of the park. So as you can imagine, this is tremendously attractive and useful to large-scale organizations, and even smaller scale data sets. You can reap a huge amount of benefit by incorporating the GPU technologies and SDKs at the right time for your use cases. Okay, that is what I wanted to cover to start with. So I'm going to pause here for a while, because I've spoken for about half an hour now, and I would love to take your questions. So.
Yes, okay. All right. Okay,
hello, Deb. Thank you for be a speaker today. Yeah, I am Dr. Panalat. I'm the faculty members here in KMITL, and I think your presentation sounds very interesting. And I think students learn somehow how to handle the data, even if it's very small. So, but I'm not sure if, because this is the audience is like a freshie and also not much background of the data science. So the question may be very simple. If I were them, maybe the question is about how we can start learning or explore the data that we may have.
No, that's a fantastic question. And that's actually one area that I'm very passionate about, where it comes to starting the learning journey. So so I'll start with an anecdote, right? So this is for all of you in the class today. When I finished my PhD and I started work, I knew C++ and I knew MATLAB. I had never programmed in Python until my first job, right? So I learned Python in sort of 2 to 3 months in my first job, because that's what we were using there, right? So lesson number one, keep learning. First lesson, the most important, you are never done with learning, right? Okay. Lesson number two, what would you do to start with? Well, if you had to start, the basic ingredients that go into a good data scientist or machine learning professional are a solid grasp of college level mathematics. So know your linear algebra, your calculus, your eigenvectors. So those are fantastic. Probability and statistics, very, very good, very useful to know, right? So master those, the fundamentals, nothing complex. You don't need to know about Riemann manifolds or any of that, right? Just know what your mode is, know what your mean is, know what a probabilistic, what is the difference between a probability and a statistic, for example, right? So know your math. Number 3, pick a programming language. I like to recommend Python these days. It is very easy to get started, and it is also very popular. So I think if you know Python and SQL, those are 2 fantastic programming languages for any data professional to do. So those are the ingredients. What a lot of students struggle with, and I myself, when I was starting my journey, struggled with was, how do you practice data science, right? How do you, and let's be honest, everyone's interest is different. Kaggle competitions are a great way. There are a lot of machine learning courses that we have online, but I also recommend heartily making your own problem. What are you really passionate about? There was this one student that I worked with, and he had a passion for gaming. Right, so if any of you play Defense of the Asian, Dota or League of Legends or any of these MOBAs, this guy basically went out and he built every few months, most of these games will release a patch note. So what he tried is, I wonder if I could look at a patch note and predict which champion would be the most popular for that patch. What an interesting problem for him, right? And that's how he learned. He learned how to build the tokenizers, how to do the parsing, how to build a machine learning problem. And I don't know how he used it. Maybe it was to build his own training strategy or whatever, but he loved doing it. Those, I think, are the 3 core ingredients. Never stop learning, know your mathematics, pick a few good languages, get really good at it, and practice your machine learning using things that interest you.
Okay, very good question. Very good answer. But I'm not sure if students have any more question. May I recap your answer to the student in Thai?
Yes, please. Yes, please.
So,
yeah.
เด็กๆ คะ คืออาจารย์ว่าเด็กๆ สามารถ learning from จาก journey ของการเรียนรู้ของคุณเดฟได้เนาะ ก็คือเขาบอกว่าเทคนิคของการเรียนรู้ที่ดีก็คือ keep learning นะคะ แล้วก็อย่าทิ้ง mathematics is very important, right? And pick one language, computer language, and recommend to study with Python nowadays, right? It's very important นะคะเด็กๆสามารถเรียนรู้จริงๆแล้วdata science หรือว่า AI หรือ machine learning หรือ deep learning มันใช้ mathematics นะคะแล้วก็พยายามที่จะเขาเรียกว่าอะไรสร้างความสนใจจากโจทย์ที่เรามีเช่นเด็กๆอยากสร้างแชทบอทหรืออยากสร้างเกมอย่างเงี้ยเด็กๆสามารถที่จะตั้งโจทย์ของตัวเองแล้วก็คือถ้าเรามี ถ้าเรามี passion ในการที่จะทำค่ะอาจารย์คิดว่าเด็กๆก็จะสนุกกับการเรียนรู้Okay, Deb, I just translate your answer to the student. ถ้ามีคำถามถามได้เลยนะคะ Okay, let's continue your session.
Great. Thank you so much for that. There's another really easy way for you to get started with machine learning. And in fact, I will probably there is something called the Deep Learning Institute that NVIDIA has. And one of the courses that I recommend you take, and it's free for everyone, is the Introduction to Accelerated Data Frames. If you go to this webpage and you sign up for NVIDIA developer account, which I recommend all of you to do, you will get access to a wealth of information and learning. This course is a quick 10-minute course, and it teaches you how to use data frames in machine learning. It has a lot of Jupyter notebooks that are available. So let me, perfect, thank you so much. So this is basically the web page. And if you click on start or enroll now, it will spin up in your browser a Jupyter notebook. And it will be connected to a GPU, and this is done at NVIDIA Zen. So we take care of all of that, and you can start playing. And we run a few code benchmarks for you. We show you how to write different codes. The most important thing is to note that these benchmarks, these notebooks that you're reading and learning from are written by some of our best and brightest data scientists. So it is a good way to see how computer software is used by the professionals, if you will, right? So that's basically a fantastic resource. And it's as easy as pie, so you can really get started. In fact, I'd recommend, if there are students in this course who want to do it right now, it will take you a few minutes, do it while I field a few more questions. I think there was one question that, so very recently, I hosted a Making a Career in AI session, and as part of NVIDIA's GTZ conference. And one of the questions that I got was, what is my education background need to be for machine learning, right? And my answer to that question is that there is no right answer. There is no right background. There are a good set of skills to have. So we covered those. So a bit of mathematics, a bit of programming, and a bit of your machine learning fundamentals. But here's another one. One of the best data scientists that I hired in one of my previous teams had a philosophy background. So completing the bachelor's, that specific student was super interested in doing machine learning, and they wanted to transition. So during the interview process, I saw enough. I saw a spark. I saw a lot of curiosity. I saw all the fundamental questions being answered, and it was one of the best hires for machine learning that I made. So the answer that I have is, what background? It used to be maybe 5 to 10 years ago that you would see a lot of job descriptions saying we need a master's or a PhD, right? You would see a lot of job descriptions for data scientists saying you need to have a quantitative degree. To some extent, you may still see those JDs, but a great way, if you do not, for example, wish to, and again, like doing a PhD is not essential for machine learning. I will say that having done a PhD, it is not essential, right? So do not be intimidated by that. A great way to showcase your interest and your ability is to have your own GitHub portfolio. So if you go to github.com, create an account, and just take Kaggle challenges or take other people's code and just rewrite it in your own way, or just run it in your own way. It's a great way for you to learn and understand, and it showcases to your potential company, if you're applying or if you start up your own thing, it gives you the comfort that you actually know what you're doing, right? So that is something I would say, it's a field that is very open. The other reason that you might be very surprised is diversity of thought. So this is another true example, right? There was a specific company, and they were looking to solve a problem on their inventory forecasting. Right, so this company was responsible for refining as oil, right? It was an oil refining plant that they're working on. And what used to happen is that they would source oil from all over the world, and they would store it in a warehouse, and they would refine it in batches. What happens is each batch of oil that you source from has different characteristics. So oil from Venezuela has different sulfur content, for example, than oil from, let's say, Doha, right, the Middle East. So you have little differences like this. And if you think of the process of oil refining, it tends to be fractional distillation, right? You just heat it up, let it cool down, and at different stages of the cooling process, it solidifies into either air fuel, or ethanol, methanol, and all these different components, right? So diversity of thought. In that team of data scientists, we had people who were specialists in automotive. We were people who were specialists who had come from a pure statistical background. And it took a lot of different angles to sit down and look at this problem and say, this is how we should solve it, right? So diversity of thought is very important. And a lot of companies who are very good at building high quality AI teams will want that. So again, it seems to be a very inclusive and open field. And I think never be intimidated by that.
I agree about the diversity. And I think the students here mostly are from mechatronic engineering and also computer engineering. I think they can work together. So we don't need people from one field, right? So it's very like to make the project high performance by basing on like many fields of people. I really agree that. So
Yeah.
I encourage students even not in the computer field to learn at least, you know, how AI or data science work or what benefit from that. Okay, so you don't need to like understand deeply, but at least you understand in the concept and can talk to the people. Okay, so I encourage students to like have a short course that Deb recommend from NVIDIA website. So that may makes you like understand more a little bit about deep learning. Okay, thanks, Deb.
No problem. So I know we have another 15 minutes. So there are 2 or 3 ways that we can play the last 15. I would love to answer more of your questions. What I would also be happy to do is if you give me an example of a project that you think would be very interesting to solve, I'd love to work through that with you and tell you how that might get implemented in industry.
Okay, may I speak to them in Thai?
Sure, yeah.
Okay, because now I assign them a project. I implemented the chatbot. So yeah, maybe this is a good place to like discuss with Deb, and then what is your idea good enough, or what any suggestion will be useful for your project? Maybe you can use that. เด็กๆคะสามารถที่จะแชร์ไอเดียได้นะพูดเป็นภาษาไทยก็ได้แล้วเดี๋ยวอาจารย์ถามเขาให้อย่างโปรเจกต์ของแชทบอทที่เรากำลังจะทำอะค่ะหลายคนก็มองว่าเอ๊ะเราจะเริ่มต้นจากตรงไหนมีไอเดียมีวิธีการทำงานอย่างไรอย่างเงี้ยสามารถที่จะแชร์ได้มีไหมถามเป็นภาษาไทยได้นะ
Don't be shy.
โอเคมีไหมคะ
ดีค่ะ
โอเคค่ะ
อาจารย์
ค่ะ
เปิ้ลเด็กๆถามได้เลยนะคะ เดี๋ยวช่วย
ได้ค่ะอาจารย์น้องแป้งใช่ไหมคะ
ใช่ค่ะ
โอเคน้องๆถามได้เลยลูกมีทั้งอาจารย์แล้วก็พี่แป้งที่อยู่ NVIDIA เราสามารถที่จะแบบนี่ specialist มาเองอะไรอย่างเงี้ยนะมีไหม Don't be shy.
Hello, can you hear me?
Yes,
Yes.
sure.
Yes.
Please.
I have some little question, but before we get to that, your presentation is really interesting. I love that. By the way,
Thank you.
I'm curious about the NVIDIA and the so let's say about my background. I've been working on the embedded stuff, you know, my controllers, FPGA, embedded Linux, and this AI stuff is really interesting, and I am currently, you know, study on that. And I have some question about NVIDIA. Like, do they offer the solution for the embedded? Like, we're talking about the edge AI, because I am instrument and control engineering from KMITL, mechatronic and automation, and
Yeah.
most of the work is about machineries and stuff, sensors in a factory, you know, and I'm looking for some kind of a edge AI solution. Do
Yeah.
you have any suggestion about the?
Fantastic question. So there are 2 parts to that puzzle. One of them is what hardware that you want to run it on, and what you want. And the second part is, what do you want this edge device to do? Is it going to be, for example, a computer vision workload, or will you talk about locomotion and a bit of robotics? So there's the hardware, and then there's the software component, right? For the hardware piece, I have just linked. Yes, thank you so much. So this particular website will give you an example of some of our edge computing solutions. And some of these are used by smart nation projects. They're used across the world in some of the most interesting AI use cases. So we have a very vast and established robotics project. So the NVIDIA Jetson platform, the Orin platform, these are embedded devices that we provide, where think of them as like baby GPUs, with a bit of from a software perspective, we have a variety of software toolkits. If it's for vision, you want to look at the NVIDIA Metropolis platform. There's something called Isaac, which is for our robotics and simulation. And if you want to go even one step beyond in the metaverse, we have the ability for you to build a virtual robot in the NVIDIA Omniverse platform. So you don't even need a hardware. If you want to test out an idea that you have in your head, you could build a virtual digital twin of a robot and try that out. And this is something which is taking a lot of organizations by storm. So this concept of digital twins, right? There is, when an organization is deploying telecommunications towers in a city, for example, there's a lot of work that goes into mapping the whole city. So the 5G rollout, for example, they would have sent robots across the length and breadth of different cities, across Bangkok, across Chiang Mai, all the different cities and places, especially with high urban density, so that they could find the blind spots and put their antennas and towers over there. We've been working with companies that are doing this virtually. So they built a digital twin of a city, which is an identical copy of every nook and cranny of a specific town in a virtual environment. We then gave it physical properties, and we drove a virtual rover through the streets and bounced virtual signals. And we used that to simulate where the blind spots would be. And when we field tested it, it was, wow, it's actually accurate. And that's when we use that kind of information to place the towers accordingly. So really, your imagination is the limit. But if you, for your specific task, I would get started with some of these DLI courses. Again, we have a lot of material available, and look at Jetson Orin as well as Isaac and Metropolis. Great question.
That's fantastic. Thank you.
No problem.
Okay. Student can check the link that Kun Pang shared in the chat box, so you can study by yourself how NVIDIA provide a tools for you. I think it's very interesting. Okay, any question? Any question คะมีคำถามอีกไหมคะ So Deb, I think you have some demo, right? So
yes, I did, but we are kind of running short of time. And honestly, if we wanted to do the demo, it would assume that we have a bit of background in the machine learning part. The DLI course I gave will be very easy for you to cover. So I wanted to actually focus on answering as many questions as I can for the team, for the students, and hopefully that's of more value. And you can always reach out to me. My Twitter handle, I'll leave my Twitter handle in here, and so that's my Twitter handle. Drop me a line, and I'll be happy to take questions and interact with you. I don't have a TikTok handle yet, yeah, so.
By the way, where is your workplace now?
I am based out of Singapore, so I'm actually
Okay.
in NVIDIA offices in Singapore.
Nice. May I visit your office sometimes?
Absolutely, you're more than welcome. Just drop me a line.
We plan to visit Singapore, like accompany student for field trip. Maybe if we have chance, like please allow us to visit your
I will.
office.
Yes, I think let's maybe we can interface with Pankil, who is our champion in Thailand, and let's see what we can do. And I'm sure we can.
Thanks.
But just to be
It's
aware,
cut
like
it here.
within our Singapore offices in NVIDIA, we have not all the people come into office all the time. We run it remotely, but we do have a few research centers and a few very good laboratories that we partner with that I think you would learn a lot from. So I'm sure we could arrange
So
something.
student can like know at least your how is the culture work of NVIDIA people and what actually people there working, something like that. So
yeah, absolutely. I mean, one of the things that we tend to have is we call it speed of light. You know, it's one of our internal values, and we say do your life's work at NVIDIA. So if you're coming here, then do stuff that you really believe in and really passionate about, and do it fast. So that's how we tend to attract and operate. So it's very
thanks in advance. Okay, student, any question more? We have like 5 minutes more. You have good opportunity to ask very specialists in the field, okay? Even simple question you can ask, don't be shy. ถามได้เลยนะ
okay. While we wait, I would say, I mean, maybe another question that I can answer is, where do I see good opportunities, right, in machine learning and AI in this region? So if you are working on chatbots, for example, you will find that a lot of organizations these days are using very sophisticated deep learning models to build these chatbots. One of the things that powers chatbots is data and language data, right? And what tends to happen is within, well, for example, the Canadian Parliament has the policy of transcribing a lot of its legal commentary in both French and English. Of course, what that results in is a fantastic data set where you can translate between French and English, right? Same thing, so Mandarin and English is a very well-known space. What tends to happen in this region is we have what's known as low resource languages, and we only call them low resource because the data to build machine learning for them is less compared to other regions, right? So examples of that would be Google reviews. Chances are a lot of them, you write them in English, right? But what about Thai reviews, right? In the Thai language. In Indonesia, for example, they speak Bahasa, and every island has its own different dialect. And that makes it interesting because they are writing Bahasa, which is different across each language. And how do you collect those data sets? So building, collecting, and working with language data sets is something that is very exciting for this region. And a lot of people are spending a lot of money and putting a lot of effort into raising the capabilities. So if you're, for example, hoping for Siri to come to have a native Bangkok offering, then you'll find that the skills for Alexa, for example, may be lacking. So that's why. So if you are keen, that's a great area for you to work in. Another thing I would highly encourage you to try is this concept of prompt engineering. And prompt engineering is when the latest generation of machine learning, I don't know if you've heard of this, but there's something called DALL-E, right? And this is almost magic. You give it a piece of text and it generates an image. And it generates an image that is incredible. So you might say, draw me an image of 2 samurai cats, you know, wearing ninja outfits or something like that, and do it in the style of Leonardo da Vinci, and it will actually give you an oil painting of 2 samurai cats, right? And so these basically, there's this concept of prompt engineering, which tells people how to design data for your machine learning to learn best from. Because these machine learning models are so complex that they're able to incorporate a huge amount of context around the world by sheer virtue of how much data they're trained on. But they're not very smart, so they're still lacking common sense. So prompt engineering is a way for you to train these machine learning models with a bit more domain expertise, right? So those are very interesting and fascinating areas to look at.
Okay, interesting. Yeah, I think it's a good suggestion if you like to explore and to be a big winner in this field. Maybe like Deb give you a suggestion about language and about prompt engineering. Okay. มีคำถามเพิ่มเติมไหมคะ
Okay. I think we are up to time.
Okay.
Pakil, is there anything else that you like me to do, or anything else that I missed out that you would love for me to share with the team?
Thank you. Thank you very much for your presentation today. Okay, Nong Bright ค่ะ
Okay, so if there aren't any questions, I would like to thank you, Dr. Deb and Dr. Panarat, okay, for today's talk. And we hope you, Dr. Deb, come back as our speaker again next time. We
Oh, thank you so
sincerely
much.
appreciate it. Yes, yes. So
I love speaking to you guys.
very
Yeah,
fruitful
it-
information.
yeah, it's very useful information. So that's it for today. Thank you, Dr. Deb, again, and thank you everyone for attending our third AIEI Tech Talk with NVIDIA. And we hope to see you again in next episode. Please stay tuned. Have a nice day. Goodbye. สวัสดีครับ
สวัสดีค่ะ
Like,
Thank you. Bye.
Thank you.
Thank you.